In this video, we're going to look at equations of perpendicular lines. Now, this question says, find the equation of a line which passes through the given point and is perpendicular to the given line. -6 and 2 is the coordinates, and the equation is 3y plus x equals 5. So one of the key things that we need to do is remember that when you've got a perpendicular line, the gradient that we want, I'm going to call m nu, is always going to be -1 divided by your original gradient, whatever your original gradient happens to be. Okay, so we need to remember that fact. But here's a problem. This doesn't look like y equals mx plus c. Everything's jumbled up here. So what we need to do is rearrange this formula so we get everything in terms of y. Well, to make y the subject, I'm going to -x on this side and -x on this side. Therefore, we get 3y equals to 5 minus x. And then, because I want y, not 3y, I'm going to divide everything by 3. So every single value gets divided by 3. So we get y equals to 5 over 3 minus... Now, x over 3 is the same thing as saying a third times x. Now, because we want it in the form y equals mx plus c, I'm going to rewrite that as y equals to minus a third of x plus 5 over 3. So now we've got our original equation in the form y equals minus a third of x plus 5 over 3. So now we've got to say, well, this is the gradient of the original equation minus a third. Now what we want to find the gradient of the perpendicular line, which I'm going to call m nu. And we said that was going to be -1 divided by the original gradient. Now our original gradient is what we have here. So I'm also going to annotate that as the original gradient, so for clarification. So m nu is -1 divided by minus a third. Now, a lot of students get stuck on this step, so I'm going to show the fractions, how you do it lower down the school. So -1 divided by minus a third. Now we know from when we divide fractions, this is -1 over 1 divided by minus a third, and m nu is -1 over 1 times, now turn this upside down so we get 3 over -1, and then what happens now, we get -1 times 3 is -3, 1 times -1 is -1, and we get a value, minus divided by a minus is a positive, and 3 divided by 1 is 3. So we get an answer of 3. So m nu is 3. That's how you get that. So I know it's a lot of steps, but in the lower years in school, you definitely know how to divide fractions. So I've just wrote everything out so you can see why we get +3. Okay. So now our coordinates are -6 and 2. So I'm going to write that here. So, okay, so we have the following. We've got m nu as 3. We've got x as -6, and then we've got y as 2. So as we did before, we just use y equals mx plus c. Remember the golden rule here, we always have to work out what c is. So y equals to 2m, which is the gradient of the perpendicular line, which we worked out was 3, times the x coordinate, which is -6, plus c. So we get 2 equals to -18 plus c, and then add 18 on both sides here. So we get 20 equals to c, and we can say, therefore, in the form y equals to mx plus c, so our gradient is 3, so it's 3x, and the y-intercept c is positive 20, so we do plus 20. So we end up with an equation y equals 3x plus 20. Here's another question for you to try. You can pause the video, and when you're done, I will go through my work solution. Welcome back. Now here's the key thing. We face the problem again. This is not in the format of y equals 2mx plus c. Now I'm going to make this in that format by first of all minusing 6x on both sides of the equation. So I end up with 3y minus 5 equals to minus 6x. Then I'm going to take minus 5 on the other side, but plusing 5 on both sides of the equation. Then I'm left with 3y on the left-hand side, and then I get minus 6x plus 5. Now, what we can do here is we want y, not 3y, so we divide everything by 3. So I'm going to divide that by 3, divide minus 6x plus divide by 3, and divide 5 by 3. So what we end up with is the following equation. So we get y equals to minus 6 divided by 3 is minus 2. So we get minus 2x plus 5 over 3. So now that we've got our equation in the form y equals mx plus c, we're in the process to solve this question. Now they've told us that it passes through the point minus 4 and minus 3. Now that's important. So we write x as minus 4 and y as minus 3. Now, as I said previously, that we need to find the new gradient, and that's going to be minus 1 over the original gradient. That's the formula we're going to use. Now, what's the value of our original gradient? M, or the original gradient here, I'm going to write original gradient. The original gradient is minus 2. So m new is minus 1 divided by minus 2. And m new is, well, minus divided by minus is a positive. 1 divided by 2 is simply a half. Try and refrain from writing a decimal. Please write a fraction because it's preferred in maths. It's just easier to look at as opposed to a decimal. You wouldn't get the question wrong if you wrote a decimal, but it's just more aesthetically pleasing to the eye to write a fraction. So now we're in the process to apply y equals mx plus c. So m new, should we write that as a half? So now we can say y equals to mx plus c. So we can say y is minus 3, m is a half, and then x is minus 4 plus c. Now we can do the following. We can say minus 3, or half of minus 4 is minus 2 plus c. And then now we can add 2 on both sides of the equation. Minus 3 plus 2 is minus 1. So minus 1 equals to c. So now we can write our final equation of the perpendicular line. So we can say y. So therefore, in the format of y equals mx plus c, y equals to the new gradient of the perpendicular line is a half. So it's a half x minus 1, because that's the value we've got for c. And that's it.